All right, let's take a look at some interfabric traffic examples with a UCS deployment, and then we'll move on to some of the recommended topologies. So here's one example of interfabric traffic. I've got an ESX host with multiple VMs, and on that ESX host I'm running a software-based switch like the vSwitch or Nexus 1000V. And I could have multiple adapters on that host, VNIC 0 and VNIC 1, and in this case VNIC 0 is going to fabric A, VNIC 1 is going to fabric B. That's a pretty typical setup. And these two VMs are on different VLANs. VM1 is on VLAN 10, VM2 is on VLAN 20. So for these two VMs to communicate, obviously they're going to need to perform layer 3 switching, and since the fabric interconnect itself is not a layer 3 switch, that flow needs to move upstream to the layer 3 network to be layer 3 switched and come back down. So VM1 egresses out of VNIC 0 through fabric A up to the layer 3 switch, could be Nexus 7000 for example, and the Nexus 7000 has to send that flow down to fabric B to come in on VNIC 1 on the very same server and be received on VLAN 20 for VM2. So this is interfabric traffic for layer 3 switching between two VMs. Now let's take a look at another example of interfabric traffic. Here we're using the Cisco UCS VMFX technology. This is where the virtual machines are passing through the hypervisor. We're not using a hypervisor switch at all on this host, and each virtual machine is really logically connected to its own virtual interface on the fabric interconnect. So when we configured the dynamic VNIC policies to enable this in the service profile, what happens there is that there will be a round-robin placement of dynamic VNICs to primary fabrics, and then fabric failover will be enabled for that. That's on by default. So because of that round-robin placement, we could have a pair of VMs here that are on the same VLAN. They're both on VLAN 10 and they need to communicate. But because they've been placed on different fabrics for them to communicate to each other at layer 2, that will have to egress out of fabric A, and fabric A 6100 will have to send that flow up to the layer 2 upstream layer 2 switch environment on VLAN 10 to come back down on fabric B and received on dynamic VNIC 2 and received by virtual machine 2. So this is an example with server virtualization, two VMs on the same VLAN using VMFX. Just another example of interfabric traffic at layer 2. Now let's take another look at interfabric traffic with virtualization. Here's another example where I've got two ESX hosts, and I've got a couple of VMs on the same VLAN again. I've got VM1 over there on ESX host 1 and VM4 over on ESX host 2. They're both on VLAN 10, and they are going to have a unicast conversation. So because VM1 is being steered out of VNIC 0 by the vSwitch or 1000V, and VNIC 0 is associated with fabric A, and VM4 is steered out of VNIC 1, which is associated with fabric B, for those two systems to communicate, they will need to traverse fabrics. So fabric A will need to send that flow up to the layer 2 upstream switch environment, which could be a Nexus 7000 or Nexus 5000 or whatever layer 2 switch is upstream, and that flow will be sent back down into fabric B to be received by ESX host number 2 on VNIC 1 and down to VM4. So just another example of interfabric traffic between two servers managed by UCS, where you have traffic leaving one fabric, going to an upstream network, and coming back down into the same UCS system on the other fabric. And this is an example for layer 2. So we've seen examples of how this is going to happen for layer 3 flows because the fabric interconnect is not a layer 3 switch, and we've seen examples for this with layer 2 flows as well. So let's take a look at one example topology. We've got a pair of fabric interconnects here, A and B, with a port channel that's singly attached to an upstream Nexus 7000 in this case. Could be any LAN switch, but we'll just discuss the Nexus 7000. And these are in end host mode. Now keep in mind all of the interfabric traffic that we discussed earlier. And we'll also throw in a new traffic flow, and that is from the network to the fabric, to UCS. So I could have traffic enter from the upstream network, from the WAN or from the other parts of the data center, enter on Nexus 7000 number 1, and that traffic is destined for a server or a VNIC or a VM that is associated with Fabric B. So because Nexus 7001 is not directly attached at all to Fabric B, it needs to send that flow across its peer link to Nexus 7000 number 2, and the Nexus 7000 number 2 can send that down to Fabric B. Same thing vice versa. If traffic enters Nexus 7000 number 2 from the upstream network and is destined for a server or a VNIC or a VM that is associated with Fabric A, that traffic as well will have to traverse the peer link between the Nexus 7000s and then delivered down to the appropriate fabric. Now recall all of that inter-fabric traffic we discussed earlier. All of that layer 2 or layer 3 traffic that has to traverse between Fabric A and Fabric B, that will also have to traverse that upstream LAN switch interswitch link to go between fabrics, because each LAN switch is only directly connected to one fabric. So as you can see here, there can be a lot of traffic potentially on that interswitch link between the two Nexus 7000s. So that's something that may or may not be a concern if, as you're sizing the deployment, as you're adding more servers and more VMs to your UCS deployment, you may need to pay attention to that interswitch link and the amount of traffic that is flowing between fabrics on that link, as well as traffic from the network to UCS. And that, of course, is if you are singly attaching your fabric interconnects to an upstream switch like we're showing here. So now let's look at the recommended topology. So we looked at the slide before where we had singly attached fabric interconnects to the upstream LAN switch, and we've also looked at before in previous videos how using port channel and VPC uplinks is recommended for all the reasons of better load balancing and hardware-driven failure across link and switch failures. We've discussed all of that. So now let's also take into consider the traffic flows we just looked at from the network into UCS and interfabric traffic for both layer 2 and layer 3. So when I take the fabric interconnects in end host mode and I attach them upstream to a pair of multi-chassis ether channel equipped upstream LAN switches, in this case it's a pair of Nexus 7000s running VPC, I get a lot better handling of traffic flows between fabrics and in and out of the fabrics. So for example, let's take a look at the same flows again. I have traffic enter Nexus 7000 number 1 from the upstream network, destined for a server, a VNIC, or a VM that's associated with Fabric B. Well, because Nexus 7001 is directly attached to both Fabric A and Fabric B, it has visibility to all of those MAC addresses for both fabrics, so it can deliver that traffic locally on one of its local VPC member ports, and that's exactly what it does. That traffic does not have to traverse any peer link to another Nexus 7000. Excuse me, same thing vice versa. Traffic enters Nexus 7000 number 2 from the upstream network, destined for a server, a VNIC, or a VM on the Fabric A, and because Nexus 7000 number 2 is directly connected to both fabrics, including Fabric A, it's able to deliver that traffic locally on one of its VPC member links on the green port channel, and that traffic as well does not have to traverse the peer link. And remember all of that layer 2 and layer 3 interfabric traffic that we looked at before? Well, the good news there is all of that is going to be locally handled by each upstream LAN switch. So in this case, I've got interfabric traffic between A and B, and when that arrives at Nexus 7001, it's connected to both fabrics, both the green and the red port channels, so it's able to locally deliver that traffic, either layer 2 or layer 3 flows, because the Nexus 7000 is a layer 2 and layer 3 switch. Same thing on the other end as well. Any interfabric traffic originating from the B, needing to go to A, that will be locally handled by Nexus 7000 number 2. So as you can see, this is really an ideal configuration in terms of scaling the bandwidth. None of this traffic is traversing the peer link. The peer link here for VPC and the Nexus 7000s is really just there for state synchronization and control plane, and all of the traffic, interfabric traffic between 6100A and 6100B, and all the traffic from the network to UCS has been handled locally by each Nexus 7000. So this is definitely the recommended topology, is taking your UCS fabric interconnects and attaching them upstream with VPC port channels to an upstream VPC domain, such as you can build with the Nexus 7000. You get ideal traffic management, and you get better failure handling, hardware-driven failure events that you get from VPC and port channels for link failures and upstream switch failures. Now, what if you don't have VPC in your data center? Well, that's okay. We can still leverage the capabilities of end host mode, and we can still use port channels where we can. So remember, I said that if you can use port channels, definitely do that. So here's a scenario where we have our fabric interconnects A and B, and we've got 4 ports available that we've decided to use on each fabric for uplinks to the upstream LAN. And because I've got 2 upstream LAN switches there, and I do not have any VPC capabilities, what I'll do is I will take 2 physical links and create a port channel, and I'll do that twice on each fabric interconnect and redundantly attach each 6100 to each upstream LAN switch. So I get some of the benefits of port channel link resiliency and convergence for the port channels that I've created, as well as I also have upstream switch failure resiliency. So if any of these upstream switches fails, we'll have end host mode engage with dynamic repinning and gratuitous ARPs to handle those failures. And we have all links forwarding for all VLANs. All logical uplinks are forwarding on all VLANs, and that's thanks to end host mode and dynamic pinning. Now here's another look at a scenario where we don't have VPC in the topology upstream, and that's okay. And here's where I may only have 2 interfaces or 2 uplinks available per 6100 for linking to the upstream LAN. Now, rather than taking those 2 links and making a port channel, what I've decided to do is instead make my first priority to redundantly attach each 6100 to each upstream LAN switch. That was my first priority. And if you have more uplink ports available, then you can make your second priority adding port channels. But since I only have 2 uplinks available on each fabric interconnect, I'm going to just go ahead and redundantly attach each fabric interconnect to each upstream LAN switch. With end host mode here, I still have the benefits of all links forwarding for all VLANs. I don't have any spanning tree influence on the topology. There's no spanning tree processing running here between the fabric interconnects and the upstream LAN switch. And I still have upstream LAN switch failure protection as well. So if any one of those upstream switches fail, it will not completely take down any one of the fabrics. So this would be the recommended topology without VPC, and if you only had 2 10 gig links per fabric to uplink to, again, really make the first priority redundantly attaching your fabric interconnects to separate upstream LAN switches, and then make your second priority to make port channels if you can.